Well, I appreciate everybody letting me crash the party here, playing with the cool marine biologists. Um, my intention for attending the meeting is just because as director, we noticed through the years that there's not much interaction among the different acoustic telemetry networks, and I think that's a shame because I think there's a lot to be learned. So this was my attempt to first attempt to kind of just try to get acquainted with what folks are doing here and just start associating names and faces. So I serve as the director of GLaDOS. I started that in 2019. My predecessor, Chuck Kruger, actually started the GLaDOS network in about 2010. So I've been taking the reins since then. So one of the institutions you need to know, or how's the camera here? Is it good? We good with the camera here and all that? Point up a little bit, just because I'm a little bit taller than the average bear.
Perfect. Yeah, that'd be good.
Yeah. Yeah, that's not possible. How's that? Is that any good?
That's good.
All right. Anyway, so one of the things you need a name to keep in mind is the Great Lakes Fishery Commission. The Great Lakes Fishery Commission is actually an international commission. It was set up as a treaty between the United States and Canada to combat invasive sea lamprey prey when they got into the Great Lakes, when the Welland Canal was built. And so the primary impetus behind the GLFC was to control sea lamprey, but the other mandate they had was to coordinate research as well as management activities, and that's where kind of telemetry comes in. So that was the beginning. In the 1970s, the Lake Erie walleye population, which I'll talk about here in a minute, crashed, and that really precipitated interagency collaboration. So it's this need and this drive for interagency collaboration that really is what makes GLaDOS work today. So just for context here, there are 5 Laurentian Great Lakes. The largest, Lake Superior, is what we refer to as the bathtub. Very, very few nutrients. On the other end of the spectrum is Lake Erie, which is equivalent to a farm pond. So I like to say in Lake Superior, we can name the fish in Lake Superior, and in Lake Erie, we have to give them numbers. Just because of the difference in the productivity as well as fish production. Anyway, that's a real brief overview of the Laurentian Great Lakes. So what is GLaDOS? So GLaDOS is a binational consortium of scientists who use telemetry to understand fish behavior and provide this information to managers. So basically, our primary function of GLaDOS is to connect acoustic telemetry researchers and their projects, very much what your network here is trying to do, very much what OTN does as well, right? And we do this primarily through a database, our online database and portal, as well as our annual coordination meeting. It's usually about a 3 or 4 day event where we get everybody together and we basically talk about a lot of the things you're talking about here. GLaDOS also, what we focus on providing is the infrastructure. I've kind of changed, GLaDOS has morphed over the years, and I've kind of set up our budget to really start providing the infrastructure needed for these telemetry projects, and then as well as providing assistance when it comes to study design and data analysis. Initially, GLaDOS was started in 2010 with 4 main projects, and that was basically just to demonstrate the utility and feasibility for conducting acoustic telemetry in large environments. Now, the ocean is just a little bit larger than the Great Lakes, but there was actually a great question about whether or not this was even feasible or doable. And as time went on, as we were able to demonstrate the feasibility and the utility, the network continued to grow, and there were more and more partners. So the vision of GLaDOS is very simple. It's basically to unravel the mysteries of Great Lakes fish. And our mission here, this is kind of what keeps us grounded, is to facilitate and conduct acoustic telemetry research in support of fishery science and management in the Great Lakes Basin. So perhaps the 2 most important words in that sentence are in support of. So basically, we are not trying to provide managers with anything new. What we're trying to provide them with is information that their traditional assessments are unable to provide, right? There's a lot of trawl surveys, there's a lot of gillnet surveys, that kind of stuff. We're not trying to replicate that. What we're doing is trying to augment it and provide them with information they cannot get from any other method or means. Our data policy is pretty simple. Each principal investigator determines who can access their project's detailed biological tagging data and subsequent detections of those tagged fish, consistent with their own agency or funding source policy. To facilitate collaboration and planning, receiver locations and dates of operation are available to all members. Non-members do not have access. And so the threshold to membership is you have to demonstrate that you have some rationale or reason for being involved in the GLaDOS, right? We have lots of requests for fishermen saying, hey, I'd like to be get information. Like, well, what role do you play in the research? Now, if they're a captain that helps us tag and whatnot, then that's different than just the average person. So that's kind of our threshold. So GLaDOS serves basically as a data service or tool where we're gathering information and then transforming that data information into something that's usable or more usable by the end user. And we encourage members to collaborate. That's why we have our annual coordination meeting, but that is left up to the individuals. We try to create the atmosphere and the community to do so, but we do not dictate or mandate that from above. Real quickly, just some of the statistics on GLaDOS. As a director, I kind of keep my eye on like, how are we doing, where are we going, and so on for planning. And I am kind of blown away every year when we put these numbers together, because we've just consistently seen increases. I thought at some point we would plateau being this far into it, but we still continue to see increases. So with respect to the number of cumulative projects, we had a 17% increase in 2023 membership. I'm pretty sure, I thought we would have tapped out all the people who would be doing telemetry research in the Great Lakes, but continue to find more people from diverse backgrounds and expertise, as well as the organizations, 119 organizations, which again blows my mind. The fish detections, that's how many, 807 million detections match the fish. Now, I would argue we're cheating in some respects, because a lot of our projects are using, or quite a few of our projects are now using HR receivers, which generate lots and lots of detections in a short amount of time. But this next two are really the ones I keep an eye on, is do we keep feeding the beast? Last year we had 4,200 fish that were released into the Great Lakes Basin, and we had 3,300 active receiver deployments. So those are the two statistics that I really kind of try to keep my eyes on. Through the Great Lakes Fishery Commission, we have this thing called the Council of Lake Committees, and basically that's representatives of everyone who have signed on to the Joint Strategic Plan. Those represent tribal, provincial, state, federal, and federal agencies. They all sit down on these lake committees, and they are the ones who identify research needs and priorities. So we listen intently to what they're saying, and we kind of, as a GLaDOS core, we try to develop projects that meet those needs. If we take a look into the number of fish that are tagged just numerically, far and away walleye, I call them the great whites of the Great Lakes. Surprisingly, that does not resound with anybody, especially in an audience like this, but hey, they're an apex predator, they're all over the place. I'm still sticking with it. So approximately twice as many walleye have been tagged in the Laurentian Great Lakes than any other species. The top three there, walleye, lake whitefish, and lake sturgeon, of course, are all native. There you have the sea lamprey. There's efforts for control and eradication of them using telemetry. Not as much in the recent years, but early on, they were quite a bit, they were studied quite a bit. Now, before I kind of put up the receiver network, because that tends to be a little bit of a problem, people are like, well, how do you do it? Well, this is how we do it. The Great Lakes have what we call the Large Vessel Program, which is operated by USGS. So these are a series of 6 vessels, large vessels, anywhere from 75 foot and larger primarily, that are out working on the Great Lakes. And so we've worked through time to leverage them, with the deployments. And that has been a huge boon to the research for us being able to do what we want to do. So this is very, very quickly, this is an animation of the evolution of the GLaDOS array. We started off with 4 projects, as I said, in 2010. And then slowly, as time grew on and more projects came on, we started deploying more and more receivers across the basin. I got in a little bit of an argument with the director at the time, and I said, hey, I'm taking all my receivers in Lake Erie and I'm redeploying them across the lake. He's like, no, you're not. I'm like, yes, I am. And that went on for about a year. But the reason we did that was so that we could we more optimally utilize the receivers we had. And we found we could by deploying them in this grid-like system. Let's see, how do I do? There we go. So today, this is what as of the end of 2023, what the GLaDOS array looked like. I'll note that we don't just put receivers out for the sake of putting receivers out. They are all tied to projects and objectives. So as more projects come online, it's my job really to figure out how to get those receivers there. But we don't put them out just for the sake of putting them out. So real briefly, we'll talk about walleye, a couple of the projects. So they're economically and ecologically important species in the Great Lakes Basin. So I'm going to talk about here about a science transfer project that developed because of this. So there were 6 projects on Lake Erie that used walleye in the eastern and the western basins. And there were close to 2,300 fish tagged since 2013. And what the managers wanted was a synthetic tool or a synoptic tool that they could use to basically pool all these projects together to draw some inferences on what fish are doing in the lake. And just for context here, this is the population abundance of walleye in Lake Erie. You can see it ebbs and throws through time. And it is a species that is managed by quota. And during the early 90s, you can kind of see what was going on. There was issues with the population modeling, and while the population was actually tanking, quotas were increasing. So there was this disjunct of what was going on in the population versus where quota management was going. So that was the impetus for me getting involved with the telemetry stuff, is if we could provide better data. So again, some of the early telemetry studies, we were tagging fish and letting them go throughout the basin. So early on, we were starting to learn quite a bit. Oh, they're in the Western Basin, they move out, they come back. And then we started deploying our receivers in a little bit more of a different manner. And then more projects started coming up in the Eastern Basin. So what you see is the brown and the yellow dots in the eastern end of Lake Erie. These are different stocks of walleye being tagged. And so there are a lot of fish doing a lot of different things. And so the question was, well, how can we start synthesizing this information, for managers to use better? So you got a lot of things going on, and it's like, well, animations are fun and cool, and you can't really do a whole lot with them. So that precipitated us working directly with the Lake Erie Committee to develop this science transfer project. And basically, we sat down, we said, okay, how do you want to group your receivers to represent different management areas? And they came back with this scheme: Western Basin, Central Basin, and then Eastern Basin, and then those fish that move northwards into Lake St. Clair and Lake Huron. And so what we did is we developed this Shiny app. So it's a web-based tool, and it may be a little bit difficult for you to see here, but what it allows is the managers to pick which spawning basin of fish they want to look at, which year they want to look at. Like, okay, so if you want to just look at the 2018 year, you can just select that, or you can select multiple years. What time period you want to use, we worked with them to identify the time periods. And basically what we developed is this simulation, this tool on this portal tool where they can sit at their computer and take the data and actually run the queries that they want. And so we were able to provide them the service where they can go and look at, like, okay, well, where were these fish in the spring or the summer, in the winter or in the fall? And the reason for this was I got tired of answering the requests of my manager or my supervisor saying, hey, can you put these figures together, right? This just, nobody was getting anything done. So this was basically hearing what the managers wanted and needed and developing this tool for them. As I mentioned earlier, there's a lot of stock assessment work going on in Lake Erie. This hatched area here shows what they used to refer to as the walleye habitat in Lake Erie. About the first year telemetry data blew that assumption and theory out of the water. But the question was, well, what implication, do these walleye movements have to our surveys and whatnot? So one of my colleagues, Dr. Krause, took the telemetry data, and then he also had sensors. We had sensors on these fish with the ADST tags. And we're starting to get a look at, what temperatures and what depths were these fish inhabiting during different times of the period. So during the winter, you could see during cold water, they were fairly shallow. During the spring, they were warming up. They were going even more shallow, but they were setting up in their spawning aggregations. As summer came along, of course, they were finding a little bit warmer water, and they were going deeper, and they were hovering. That horizontal pink bar represents the thermocline, and usually below the thermocline, it's anoxic. And so the idea is, how are these fish relating to different environmental conditions going on out there? And then this next graph shows where these fish are detected in the water column. But in this case, the yellow graph represents the keg gill nets that they run for their survey gears. And so how susceptible are the fish during these different times of year to the surveys going on? So this was just one means of kind of getting at some of those things of, hey, what habitats are the fish using when they're out there? And what does that mean for managers? Real quickly, we're also working with another project. We're looking at the contribution of different stocks. So we literally went out and worked with commercial fishermen, and we tagged fish both in the recreational and off the commercial fisheries. And we said, hey, where do these fish go? And so this animation right here is basically a heat map that shows where the fish are moving, on, I think this is a monthly time step. No, this is a weekly time step throughout the course of the year. So this is a fairly recent tool I had one of our programmers put together. And basically it's just an animation of the heat maps all tied together. So this is very powerful for the managers getting an idea of where these fish are during certain periods of the year. What you'll notice is during the winter, everything kind of goes blue, meaning there's very, very few detections. And what we think is going on there is that when the fish are not very active at all, where they're basically just kind of sitting tight and they're not getting detected on their receivers. I'll skip ahead and say the other end of this, or the other aspect that we're working actively with the managers, is they're trying to reintroduce Cisco into the Great Lakes. Cisco are basically the forage base in all the Great Lakes. They're herring, and they were extirpated in quite a few of the lakes. And so there's active efforts ongoing to reintroduce these. And so this is the Cisco reintroduction plan, and each lake is a little bit different. But one of the key aspects to a lot of this restoration plan is like what role stocking plays, and like how effective is stocking, and how can we increase survival. So we've been working with, this is in Lake Huron, where one of our researchers took the predation tags. I believe these are the 180 kilohertz predation tags, and looking at the movements of these fish, getting an idea of what these fish do post-release. And then in the background of these animations are wind direction and velocity. So here we're trying to take the movement information and marry that with the abiotic condition of what's going on in the lake at the time to get a better understanding of what's driving fish movements and perhaps survival. Here you can see the fish was just eaten and it was bouncing around. So this is actually quite informative to the managers in terms of like, whether or not these fish stay near shore or near the stocking area, or whether they disperse. Another project here looking at post-release survival of these corygonids is in Lake Ontario. And basically the study design was that they stocked them at 3 different depths. They wanted to see what survival looked like. And so then using Kaplan-Meier survival curves, we're able to show that, hey, those fish that were stocked offshore actually had the highest, at least post-release survival of the 3 cohorts that were released. So then ultimately what we want to be able to do then, of course, is to kind of say, hey, how do we take these fish movements and relate them to, abiotic conditions going on? This nice, beautiful fluorescent green that you see up here on the screen, there's harmful algal blooms, right? If you're in the Chesapeake Bay, you're familiar with those. And so how do fish use them? Do they avoid them, or actually are they beneficial? Do they use them as a habitat? And are fish using them as a, cover? So that's what we're looking at, like how do fish like walleye and now yellow perch utilize these different areas? And then we have these anoxic zones that set up, and then how do fish relate to anoxic zones? So we're finding out a place, I think, with our receiver arrays where we can start getting into some of these more intricate questions. With that, I'll take any questions. I may have a minute or two, but yeah.
Have a couple minutes for questions. Dave's mind is blown by the array.
I just, right. I'm blown by that pot pusher. I've never seen that used. That's a great.
It's used for
idea.
sliding bodies off and for big anchors. Yeah.
Catastrophic release.
Yeah. Yes.
In your lake, in the Great Lakes, do you have a lot of vessel interactions? I look at a lot of receivers,
Yeah, our biggest issue are commercial fishermen who are either trawling for smelt in Lake Erie or pulling gill nets, and the gill nets will end up getting caught. We do provide them with a general vicinity of where the receivers are, and there's some error. We only give them 2 decimal places or something like that. We don't give them all 5. So there is some, once in a while, guys will come in from the weekend and there will be a receiver with the concrete anchor on the back door of their office. So somebody has lugged the whole unit in. Our attrition isn't too bad. I'd say maybe around 5%. So we do lose some, but it's not unmanageable. The biggest issue we've had is that commercial fishermen are convinced that these acoustic receivers block fish from moving. Like that has been the most interesting question I've had to address more than anything, but yeah.
Any other questions? We have one more.
Thank you. I appreciate the opportunity to share what's going on.
Next up, you get me actually giving a research talk for once.
Yeah, Surcat.
But so yeah, I'm in my other role, I'm Matt Ogburn, senior scientist of the Fisheries Conservation Lab at the Smithsonian Environmental Research Center. And our lab is involved in studies on a number of different species. So, you know, we do the work that we do with the ACT network, you know, a number of different migratory species. We work on oyster reefs, we work on blue crabs, we do a lot of different things. But one of the species that I've worked on the most since coming to Smithsonian about 12 years ago are, well, two species of river herring, the alewife and blueback herring. And I'll mostly talk about alewife today, but give you some initial, some updates on new projects with blueback herring as well. I have a range of collaborators here on these various projects, most of whom are with us at Smithsonian. But also we've worked with Nathan Fury and Mariah Livernoy at University of New Hampshire, Reed Nelson, who's at George Mason University, and Jack Ryan, who's with the Rappahannock tribe as their, he's not a member of the tribe, but he's the environmental director who works with the tribe on the Rappahannock River in Virginia. These are blueback herring that are spawning in the Choptank River. So despite the fact that we have a lot of coastal plain streams that you might think of really slow moving soft bottom streams, in some of the riffles there's gravel. So it's just kind of it surprised me when I moved to the Chesapeake, and that's where a lot of the river herring are spawning. And for those of you from the Northeast who think alewife spawn in lakes, we don't really have lakes in the Chesapeake watershed for alewife to spawn in. So our river herring primarily are spawning in probably the sort of the upper tidal zone and then the non-tidal rivers and streams. This is just a video of blueback herring. This is mostly how we've been studying them for the last decade. When they come in and they're spawning, we've been doing things like imaging sonar run counts. We've been doing a lot of distribution work using eDNA, looking at impacts of dam removals and stuff. But one of the biggest questions that we've had is what happens to these fish the other 10 months of the year? Where are they going? So we've started just in the last couple of years using acoustic telemetry to start to get at that question. These are at least the US-based ranges of these two species of concern. Alewife tend to be a little bit more northerly distributed, tend to come in earlier in the spring when the water's a little bit colder. Blueback herring come in a few weeks later and have a slightly more southern distribution. So you know, they're two species that are very temperature dependent and potentially heavily impacted by climate change. And so some of the questions that we have, in addition to understanding where individual fish are going, are related to how temperatures are changing and how fish are responding to that in rivers, in the bay, and in the ocean. So, so these are some of the overarching research questions we're trying to address. What time do individual fish enter and exit rivers like the Choptank River, which is where we did our first pilot study on alewife that I'll show you data from today. How do they use the Chesapeake Bay and other rivers? Are they straying between rivers or not? How long are they spinning in the bay before they move into the river or spinning on the way out, that kind of thing? What's the extent and timing of the ocean migration? And how are run timing and water temperature related sort of throughout the migration? We heavily, we have a specific array for this project in the Choptank River, but obviously heavily leveraged the network and partner networks for this. So we've talked about that a lot today. So we're using Innovacy V7 tags for these on low power with an average 3-minute delay. And that gets us about just under 400 days. So we're able to get 1 year plus a month or two, which is just enough to get the full migration and the spawning season following that. And this is an animation that Mariah put together of our first release of 50 fish in the spring of 2022 and the year following that. And you'll see where the Choptank River is as soon as I play this. It's where they're all tagged. It's going a little bit jumpy. Maybe if I play it a second time in a minute, it won't. But the fish are cruising up. We thought they might go Long Island, Cape Cod. They went, spent the summer in the Gulf of Maine. One went to the Bay of Fundy. And then around November, they started moving back south, sticking really close to the coast for the most part. And then we had 5 fish of the original 50 come back into the Choptank River. I'll try and play that again, see if maybe it won't be quite as jumpy the second time. Maybe it's going to be jumpier. But one of the things that you'll notice in this, and I'll have maps that summarize this in just a minute, is that we don't. You're probably seeing how much is interpolated here and realizing that we have very little data actually in the ocean, but we have some, and that's really exciting. So this is the abacus plot here. They're color coded. The yellow ones are within the Choptank River itself, both tidal and non-tidal. In the rest of Chesapeake Bay, in sort of the teal color, in the ocean, and then you can see the ones that come back again. So not a ton of data in the ocean, but we're getting some, and that's allowing us to start to understand some of the migration, the timing and the locations that the fish are going. So here's a summary of those data by latitude. One of the fun things that our fish have to do to migrate north is first they have to go south. And when they're coming back, they go south and then have to turn around and go back north into Chesapeake Bay. So we're going to be sort of looking at the timing of that. If you look here by season, starting in the spawning season in 2022, by one of those is hidden, the May to October summer period, these fish they're sort of, when they come out of Chesapeake Bay, they are very quickly getting to Long Island. It's only a few weeks. So they'll leave the river and within a month, 4 to 6 weeks, they're off of Long Island, Martha's Vineyard, places like that. June and July are mostly, they're sort of off the, sort of out in the middle of the Gulf of Maine. And then don't start moving south again until October, November timeframe. Like I said, it's most of the detections in the fall are really close to shore. And then some of the fish did come back to the same place. So we previously, over several years, looked at annual survival rates based on otolith aging for alewife in the Choptank River, and gotten estimates from about 10 to 20 or so %. So at worst, tag mortality might be 50%, but we're within the ballpark of annual survival rates for these fish. So we think we're doing a pretty good job with survival on these fish. And I'll show you that's with our second release, we're starting to get similar numbers, actually slightly better survival. But that's the first glimpse of alewife migrations from Chesapeake Bay, both on the northward and southward migrations. These are our fish are traveling through the areas of high bycatch and the Atlantic herring and Atlantic mackerel fisheries. And they're also spending a lot of time in places that are warming up very rapidly. So we have a couple of ongoing future projects that I wanted to mention here briefly. So our last year, we had our first project working with the Rappahannock tribe and tagged 100 alewife in the Rappahannock River. This is just a little bit south of Washington, D.C. And one of the interests that we shared with the tribe in this river is that there had been a major dam at Fredericksburg, right near where I-95 comes south from DC and goes through Fredericksburg, Virginia, that blocked migration into the whole upper portion of that watershed. That dam was removed about 15 years ago now, and we've been really interested in seeing how fish are responding to that dam removal event. And based on eDNA, we've seen habitat use pretty far up, almost all the way to Shenandoah National Park, so way up into the upper parts of the watershed. We're not quite at the point of using telemetry to track them on that extent of the migration, but there's, I think, a lot of interesting work to do there together. So this time we had enough funding to tag 100 alewife. And these were some of the early data. We have data from our receivers, but not the network yet. So we tagged 100 fish in a creek in the lower part of the Rappahannock River that's been a traditional fishing ground for the tribe for probably several millennia. And let's see, there's some basic summary here. We had data on, yeah, so these are the number of fish detected at different receiver stations on the way out of the river. So we tagged the vast majority of them, or heard from the vast majority of them on the way out. A couple of them did move upstream in the river, not like super far, but a decent ways upstream before turning around and moving back south. And then when they returned the following spring, we got 14. So I can do that math in my head, 14%. So again, sort of in the ballpark of what we expected for annual returns of these fish. Across these two projects, so we've now had 19 fish come back the year after that we detected them, and none of them have gone into another river or bay that we've heard of yet. It's possible that some from this batch might have, and we haven't gotten the data yet. But so far we haven't seen that. We expect there's some strain for these fish, but you know, we haven't seen that yet. Most of the fish that we detected back in the river came right back into the small tributary that we tagged them in, not the other tributaries, although a few were detected upstream at a few different locations, but the majority were only picked up back in the small stream where we tagged them. So our latest project, so those first two projects were funded through internal grant competitions from Smithsonian, but our postdoc Henry Leggett led a proposal to NOAA Fisheries with our colleagues from George Mason and the Rappahannock tribe that started this year. And for this new project, we've tagged 50 blueback herring each in the Rappahannock, Potomac, and Patapsco rivers. We're interested in these three different stocks because the run timing is a little bit different. It can be 2 to 3 weeks later at the northernmost site than the southernmost one. And we want to know if that's because they're coming into the bay and waiting for the river to warm up, or if these different subpopulations are actually coming into the bay at different times. We've done a bit of genetic work, and so there are at least significant but small genetic differences between these, so there are slightly different genetic stocks as well. So there are a lot of potential interesting questions that we can answer using this study design. And then next spring, we'll be tagging 50 alewife in each of these three rivers as well. And we're also collecting fish to and retaining some otoliths from additional fish Reed Nelson is going to have a grad student at George Mason who's going to do otolith microchemistry, looking at their history of use of freshwater, brackish water, and ocean environments. So there's be a lot of nice pieces of data that come together to tell the story about where these fish are going. And yeah, I think that's it. So thanks for the opportunity to share some of the research that I do as well. And I'm happy to answer any questions.
We exhibit alewife in the New England Aquarium in this very small round exhibit. It's a schooling exhibit, and seeing on sort of to Nova Scotia is making me feel really bad. We are decommissioning that exhibit. I'm wondering, do you have evidence that they stay as a school? Like, do you have individual detections side by side as they go to Nova Scotia?
I don't think we do yet.
Okay.
We haven't looked at it really specifically, and we have a pretty small sample size. I'm hoping that we can start to get at that with, once we get data back from, these, we'll have 450 fish to work with instead of 50. So I think we might be able to start to get at that. But we haven't seen it, obviously. But the timing is pretty similar that a lot of them are moving. When we tagged these, when we caught the fish by boat electrofishing for this pilot study, and we retained some of the fish that we didn't tag in a holding pen, and so we released them with friends. So we'd have a few tagged fish with a group of non-tagged fish. It's one of those things. It's like, we feel like this is a good thing to do. But we don't have data to validate that it helped or not. But yeah, I mean, it's a really interesting question, sort of how much they might be schooling. And then, Nathan Fury, one of the things he's really interested in is whether they're predators that are following them through that whole migration as well. But we don't have data for that either. But yeah, lots of great questions about fish moving together.
Is there consideration for the predation tag?
I would love to do predation tags. So I think the next proposal that we write will have that, because there's both. I mean, there's predators throughout the range, but particularly striped bass and non-native blue catfish in the locations where we're doing this tagging. And so there's potential for reasonably high predation in those places. For the initial studies, we opted for sample size to get more data in the ocean versus predation tags. But that's one of our next questions. Yeah.
The other source of loss is bycatch mortality.
Sure.
I want to ask about your survival estimate for that first part. You said you released 50,
right,
and 5 returned, and then you said survival was about 50%.
I meant to say 10%.
Oh, okay.
If I said 50%, I meant to say 10%.
So that's really low. Yeah, and do you think it is something like bycatch?
Well, I think from otolith aging, we've estimated it there. It's varied between like 8 or 10% and like 23% from year to year. Annual survival. Yeah, sorry. So I mean, I may have misspoken, but yeah. So we're within like I think what I said was that the tagging mortality is not likely to be more than 50%, because the highest annual survival rates we've estimated are about 20%, and we're seeing 10 to 14%. Yeah, maybe one more question.
So we found tagging Cisco's, which we paid. The hatchery guys told us put them in round tanks and keep challenging them, and we actually noticed a marked increase in survival by holding them in round tanks while we're tagging, putting a little flow in there.
Huh. Yeah.
It almost seems like you need to challenge them, and we noticed a major increase in survival. So
yeah, that's really interesting. I wonder if our holding tank and then pretty quickly putting them in the river is sort of a similar, like our holding pen is kind of similar, because they're pretty quickly going back into a moving stream.
Anything they can get in corners in stresses them out. So, it was very interesting.